This is totally unscripted, but if you go onto the Content tab and you look under Lecture Guides, it's down at the bottom typically. Lecture Guides if you are taking the class face-to-face. Each one of the lecture guides, and they're just rough sketches of what I'm going to cover during the class periods, are there. And I'm doing Statistics Handout, Chapter 1, Spring 2017. And there's just some highlights that I want to be able to hit with you. So, first of all, I have my very formal soccer whiteboard here, but it's the best I got. So, here we go. On your first test, I will, and I have never not asked, the definition of statistic and parameter. Now please note there is a difference between statistics and statistic. Statistics is the study of, it's the organization of, dealing with data, making decisions from data, etc. Statistic and parameter, there's no S on the statistic, and statistic and parameter are frequently used in the language of statistics. So, a statistic is a numerical description of a sample characteristic. I'll hold this up a little higher, see if I can get that in there. Now, parameter is a numerical description of a population characteristic. Both of those need to be memorized verbatim. Don't miss a word. Everything else you can kind of give a general description of, but those two I require word for word. Now, statistic and parameter. So X bar is an example of a statistic, and X bar literally has the X and the bar over it, stands for mean. Now it's the sample mean, and then mu, it's a cursive U, and it's pronounced like almost like a cow's mooing, is the population mean. Okay, so let's see if I can get that into the camera. All right, so over here on my right hand side, right over here, I'm sorry, my left hand side is the X bar and the mu. X bar is the sample mean, mu is the population mean. We have sample variance, sample standard deviation, and those are denoted S squared and S, respectively. We have sigma squared and sigma. Those are the population variance and standard deviation. And then we have p hat and capital P to stand for proportion or percentage. Forgive me for 1 second. Let me scroll on my sheet here. On the second page of that handout is two words that we need to define: random sample and simple random sample. Random sample is each member of the population has an equal chance of being selected. Simple random sample is a little bit more challenging to get, and calling it simple seems to be a little bit of a misnomer. So, if there are 10 items in the population, and we're trying to draw out groups of 3, every possible group of 3 in every possible order has an equal chance of being selected. That is an example of simple random sampling. It's important when we start talking about the idea of getting a sample mean being greater, where the mean sample size is approximately 25 or 36, and you have to understand the probability of each one of those samples being selected. Levels of measurement and types of data. Two types of data, qualitative and quantitative. Qualitative is hair color. It's equality. It's gender. Things that don't have a numerical value attached to them. And be careful with that, because if I say a number on the back of a jersey, that's a quality, not a quantity. You can't really do numerical computations with with the numbers on the back of a jersey. They're just numbers to represent that individual. Quantitative, you can maybe add, you can subtract, maybe multiply, divide, depending on your level of measurement. Age is a quantitative, and I have to be careful with that because sometimes people will be categorized as a senior citizen or middle-aged, and that at that point in time you'd be looking at something that's qualitative. So levels of measurement are nominal, ordinal, interval, and ratio, and they're sort of built on level of complexity. Nominal basically means in name only. Ordinal is something you can put in order. Those are both generally qualitative types of data. Now, ordinal can go down into quantitative because you can order things, and if there's a reasonable numbering system applied, you can add, subtract, etc. So a nominal level, in name only, red car, blue car, type of dog. Ordinal, you might have Friends being the most popular show, you might have Cheers being the next locations. You can't say first plus second gets me my third. Friends plus Cheers is equal to ER. It doesn't make sense. The shows are dated, but so am I. Now, interval and ratio are a little bit more challenging. Interval is temperature. That's a good example of interval. Ratio is money. Anything that's weight or height that's measured on like a ruler or on a scale typically is ratio. The way you can tell is two things. You have mathematical zero. So for golfers out there, if you said to me a golf score, I went and played golf and you shot a 0, that meant you got as many strokes as you're supposed to get with golf scores. That's an interval relationship. If you talk about I have that being a mathematical concept, that's the mathematical zero. I have the absence of dollars. Another way to tell is if you think about doubling. So I'm going to talk about temperature real quick. In the middle of winter, if it's 2 degrees, and the next day it's 4 degrees, our temperature's doubled. But I haven't changed how I'm going to dress. It's still cold out there, and I'm still wearing my parka and my jeans and my long johns and my socks and my boots and my hat and my gloves. Okay? But if you go 50 to 100, again, doubling, 50 degrees, I'm wearing a sweatshirt and a pair of shorts. That's me, I run pretty warm. At 100 degrees, I'm done. And so that doubling relationship doesn't hold. But if you think about it in terms of ratio, in terms of money, if I have $2 today and $4, I go from $2 to $4, I've doubled my buying power. If I go from $50 to $100, I've doubled my buying power. So that concept is how you determine if something is ratio or interval. And that tends to be where we struggle a bit. Now, I'm going to freeze right there. Make sure you look at all of the bullet points in the or on the lecture guide. But when I ask the question about levels of measurement and types of data, what I will say basically is what are the two types of data, or what are the types of data, and what are the levels of measurement, and give me examples of. And I might have you pick one or two. Like I might give a question that says, this is what form, and explain why you think that. And there is some gray area in there. There are times when things can be argued differently. For instance, if I give you a bag of sugar and I say, how are you going to measure this? Well, somebody might count the quantity of granules of sugar. Seems a little bit silly, but somebody might weigh it. So depending on how you look at it, somebody might look at the label and go, oh, it's blue. Now we've got nominal data versus ratio data. Be careful and think about how you're using the data, because application becomes important. It's not a major point, but people get stuck on it and hung up on it. I'm going to sign off now, and hopefully you guys have a good day.